Yeah, I think it's actually recording. I think.
Check.
There's a little black square up on the top part of the screen, up there. I think that means it's recording. It's just gone wrong so many times that I don't trust it anymore. Okay, so we're gonna get into polar coordinates today. What's the coordinate plane that you've been used to working with in algebra, geometry, other two? Yeah, XY. They also call it the Cartesian coordinate plane. And the Cartesian coordinate plane is just a way to locate objects in space. So, if you want to tell someone where that point is in space, all you need to do is give them a reference point. So you say, my reference point is 0, 0. And you go right this far and up this far, and that's your XY coordinate. And that's one you're used to. There are other coordinate systems. There's tons of them once you get up into higher dimensions. But the one that's most popular, other than XY, in 2 dimensions, is called polar coordinates. So instead of telling someone go this far right and go up this far to get to a point, you could also tell them to go out this far. So you could say, go out this far for your radius, and then rotate this far this many degrees. And that's another way you could tell someone how to get to that point. Go out this far and then rotate until you hit that point. There's 2 coordinates that are associated with this, r and theta. And you can plot points in the coordinate plane just the same way you can with XY coordinates. So we're going to be solving problems and converting between Cartesian coordinates. Yeah, so.
Why do you ever use that?
It's really useful once you get into like 3-dimensional modeling, especially. We use it in like engineering, calculus, things like that. I don't know if you noticed, but you're in a pre-calculus class. So everything is oriented towards stuff you need for calculus. Pretty novel idea.
So is this the sort of stuff that we use on ships to, like, oh, you have to go such and such amount of degrees at such and such speed?
Yep, that's polar coordinates. Any more good questions? Okay. Yeah, we don't need that. Okay, we just want to get right into plotting points. Again, we're just locating points, but just with different coordinates. So, how would you plot the point 4, negative 3 pi over 4?
4 little lines over 4.
So 1, 2, 3, 4. Go over 4.
Oh, you're going to go down, like instead of like going up, you have to go like down. It's like saying.
Yeah, so we're going negative degrees in this one, so we go down. So
Continue past that. Yeah.
About right here.
Yep.
Is that it?
Yes.
Yeah. Preference. You can label them however you want.
Okay. So number 4, other part, I missed it. I was freaking out about the line.
You're freaking out about the line. Okay, so we went out a radius of 4, so our r here is equal to 4. And then we rotated negative 3 pi over 4. And that's in radians. How many degrees is that?
130.
Yeah, that's negative 135 degrees. So we went negative 135 degrees. And that's how we got to that coordinate. What do you think about that thus far? Is that wasn't too bad. So
Awful. I'm just putting
oh, that's a 4 on the baby scale. Okay, got it.
Why is there a polar bear?
Polar coordinates, polar bear. Very funny stuff.
I like that.
Very funny. Yeah, there's a lot of polar bears, very polar bear themed notes.
Ooh, that'd be good.
So on that last one, we had a radius of +4. What do you think happens if we have a radius of -4?
You go to the left.
Yeah, so you can just start on the opposite side. So like for this one, we have the point -2 and 2π/3. So label this however you want. I'm gonna go 1, 2.
We don't have that fancy thing.
Yeah, we don't have a circle.
Oh yeah, I had to add these. Do your best to draw them. Yes.
Or go back to
Or
the
just go to the
Or you can
Yeah,
go back
that's
to the
last
previous
grid.
slide. Yeah, you can use the last grid. Yeah, for your homework, we're gonna pass out some polar graph papers.
So, do we still go?
So you would go out to -2, right? And then you want to go 2π/3. If it's positive 2π/3, you go down because we're going counterclockwise in the positive direction. That's the positive direction.
Okay.
So we go down 2π/3.
So are we supposed to like
It'll be really helpful. But in this case, because all these are labeled, we started here at pi. We started at pi, right? And we went 2π/3. So we just added 2π/3. And if you simplify that, that's 5π/3, which is where we are. Did you not understand why that's 5π/3?
No. Yeah.
Pi is like 3π/3. What do you think about this? Just plotting these points. Okay.
I'm making that into
It's probably gonna get really hard.
We need to carry down.
Okay, right now. Let's plot one more.
I know.
Let's do plot this. -3 π/2. Plot that.
Okay, I'm gonna do it on this one.
So you go up. Don't go down. Oh.
Go out to -3. I'm going to start at -3, and then I go π/2. Which direction? Down, yeah, counterclockwise. So there is your point. Okay, 1 out of 4. Where are we at? Just plotting points. Okay, sounds good. Okay. So with xy coordinates, every xy coordinate refers only to one point. If you say, 1, 2, that just refers to one place. Polar coordinates can actually have infinitely many coordinates, all referring to the same point. Do you have any sense of why that is?
Circles.
There's circles, yeah, you can just keep adding 2π. So like on this last one, let's look at this one back here. If we had this point right here, that was -3 π/2, how could we get back to the same place?
Negative. If you go like -5/2.
We could just add 2π.
I'm not.
You go here, go around the circle once, adding 2π, and you're back at the same spot.
Wait, how is that different from like another graph?
How is it different from another graph? What do you mean?
Like, because if I have a graph of 45 degrees, I can add 2π and go back around.
Right. Yeah, no, you're describing polar coordinates. Yeah.
I have 1,000 pounds.
So if you add 2π, you're back at the same spot. Those two coordinates, these refer to the same point. And what I said with the xy coordinate plane is that it doesn't work like that with xy coordinates. You can't add a certain amount to x and get back to the same place. So what you might see on your homework is that it's going to say, I want you to find a particular polar coordinate, but it's going to give you restrictions on what theta value it wants, or it might give you restrictions on the radius. So here it says, what are the coordinates of the point shared with 3 pi over 4, given that r is positive, so we have a positive radius, and theta is in between 2 pi and 4 pi. The first thing you want to do in these instances is actually graph the point. So if it's 3 pi over 4,
Well, with something like that, since we just have to add 2 pi to get to the point again.
so
But does the 3 have to stay constant?
the 3 won't change in this one. So we go out 3, up pi over 4. That's our point. And it wants another point that refers to the same spot.
Plus 2 pi.
3, 9 pi over 4.
3, and that's, okay, so you did pi over 4 plus 2 pi. So yeah, like other people have been saying, you just add 2 pi to get back to the same spot.
So like, if there weren't restrictions, would you be like -3 and whatever? That's not. So I feel like
Yeah, if there were no restrictions on r, you could get creative with that. We'll do that in the next problem.
Okay.
Look at this next one. It doesn't restrict your angle this time, so it's not, well, it does restrict your angle, but it also restricts your radius. So in this one, it says r is less than 0. So we want to have a negative radius. We want to have a theta value in between pi and 3 pi over 2, but we still want to end up back at the same point. So let's first figure out, let's graph that point again. I'm going to come down here, and I think we labeled that 3. That was our point we wanted.
So then your radius would be -3.
So because we said r is less than 0, we need a negative radius. And why does it have to be -3?
Because it has to be on the same circle, but
We still have to get to this point. We have to go out 3, but we want it to be less than 0. So -3. So -3 would be out here. So we'll start here.
yeah.
Is it 5 pi over 4?
Yeah.
So we have to go all the way around the circle, get to this point, and that turns out to be 5 pi over 4. The way you can think of that is our original point was pi over 4, right? What did we have to add to get to that point? Yeah, we just had to add pi. So when you're dealing with the negative radius, it's often enough to just say, okay, here's my negative radius, it's -3. I want to go pi over 4, but because I'm negative, I need to go another pi to get to the point.
Can you go to the one above it?
Sure. Where are we at with this right now? Between 1 and 4. You can see a little bit of feedback here.
This means 3.5, just so you know. This means 3.
Got it. See what else we have for some practice. So, kind of the big thing we get into here is converting between polar coordinates and xy coordinates. I said that both of them are just ways to get to a point. We can convert between them. And this is where all that trig that we did yesterday comes in. So, rectangular coordinates are xy and polar coordinates are r theta. Let's, and you should do this on your notes, draw a little coordinate plane. And if we have some point in the xy coordinate plane, are you getting this down?
Yeah.
And it's an xy coordinate. We'll do our thing where we draw the triangle. What's the bottom leg of this triangle? X. We go over in the x direction. What's our other leg of our triangle? Y. And then we call this the radius. This is R. So if we want to get a relationship between our polar coordinates, which are r theta, and our rectangular coordinates, we call them, which is x, y. Here's our r. Here's our theta. We just use sine and cosine. So cosine of theta is just x over r, adjacent over hypotenuse. And sine of theta is y over r, opposite over hypotenuse. So now you can solve both of these equations for x. Do you see how they went from this step to this step? They have cosine theta as x over r. They just multiply both sides by r to get x is equal to r cosine theta. Same thing here. Sine is y over r. So they just multiplied both sides by r and got y equals r sine theta. Do you see how that relationship works? So if you know polar coordinates, if you know r and theta, you can go to xy coordinates just using this relationship right here. So if you know r and theta, you can go to xy. 1 out of 4. Does that make any sense? Okay, let's try and practice with it. You know some polar coordinates, 3 and 2 pi over 3, and you want to convert to rectangular. And this is going to be the relationship you use. X is equal to r cosine theta, and y is equal to r sine theta. First thing you want to do always just plot the point. It's 3, 2 pi over 3. So I'm going to go out 1, 2, 3, and then over 2 pi over 3. Here's my point. I'm interested in the xy coordinates. What was that? X won't be negative.
I got that x equals negative 1.5.
Negative 1.5. So what did you use?
Like I put like 3 and
So you did this. 3 cosine 2 pi over 3?
Yeah.
Okay, yeah. And y is equal to 3 sine 2 pi over 3? And for that first one, Chloe, you said you got negative 1.5. What about for that second one? 3 squared to 3 over 2? Or 2.6? So again, we're just using our polar coordinates to rectangular coordinates formula. So our point then is x is negative 1 or 1.5, y is 2.6. That's the coordinate of this point in rectangular coordinates. And that kind of, I mean, the reason you want to be graphing all these is you want to think, does that make any sense? Because if you had gotten a negative y value, you obviously did something wrong because we're in positive y direction. So it's negative 1.5, 2.6. Do that next one. It's -2 and 95 degrees. It's in polar coordinates. You need to figure out the rectangular coordinates.
Is it 0.17 for x at negative 0.199 for y?
0.17 and -1.99. Same thing? Anyone? Yeah? Okay. Let's graph that polar coordinate to see if that makes any sense. So if our polar coordinate was -2, 95 degrees, where am I going to start? I go out -2. We'll say here's -1, here's -2. So we'll start here, and we go 95 degrees, up or down? Down. It's counterclockwise, positive direction. So go roughly, let's say that's about 95 degrees, since that's 90. So, does the coordinate that we got make sense? Does 0.17 -1.99 look like it could be right?
Yes.
Yeah. I mean, we barely went over in the x direction. We went down substantially more in the y direction. I think that's a believable point. Alright, where are we at on converting polar rectangular? 1 through 4. Okay. Now we're going to go the other direction. We know the rectangular coordinates, so we know where a point is. Call it xy. And we want to get the polar coordinate. So we're looking for r theta. Again, I would draw a triangle on your page to see these relationships. We can make our little triangle. The base of our triangle is x. The other leg is y. Our hypotenuse is the radius. And then we call the angle in here theta. Just a triangle made with any xy coordinate. What's tangent of our angle? Y over x? Yeah. So if we take tangent of our angle, we get y over x. Well, if we know something that's in rectangular coordinates, we know x and y. So, using x and y, we can solve for theta. How can we solve for theta? Inverse tangent. You can take the inverse tangent of both sides to get theta is equal to inverse tangent y over x. For polar coordinates, we're not only interested in theta, what else are we interested in? Radius, r. How do we solve for our radius? Yeah, just the Pythagorean theorem. X squared plus y squared is r squared. So if we know x and y, we know some kind of rectangular coordinate, we can solve for both r and theta. Let's put that into practice. We have some rectangular coordinates. We want to convert to polar form. I always sketch right away. Negative root 3. So we'll go out, say that's negative root 3. Up 1. We're about right here. And we want to get the polar coordinates. So we want to know the radius. And we want to know the angle. How am I going to solve for theta? Yep. So tangent of theta is y over x, which means theta is equal to inverse tangent 1 over negative root 3. So that's our y, that's our x. Who's got it? Negative 30. Where is negative 30 if we're graphing that angle? Here's 0. That's negative 30 degrees right there. That's not the angle we're interested in. We're interested in this angle, the angle we make with the positive x-axis. I hear 150? Yeah, these are supplementary angles right here, theta and negative 30. So the angle we're really interested in is 150 degrees. This is, again, while I'll say it 100 times, you need to sketch these things, or else you're going to get answers like negative 30 and go, I don't know what that means. Yeah, so yes. If you did, you're saying if you did a negative degree and a negative angle?
Yeah.
Or a negative radius and a negative angle? Yeah, you would. So you could, okay, I see what you're saying. We'll finish doing it this way and then we'll see what you think. Yeah.
Wait, so anytime it's negative, you just add 1 to it?
You might, I don't want to say anytime because sometimes you might add 180, sometimes you might add 360. You always want to make a sketch. Like for example, you might have a problem where the point is down here instead, and you get a negative angle. Well, in that case, you need to add 360, not 180. So I don't want to make a hard rule here. You need to sketch these things. We found our angle. How do we find our radius?
Square root of sides.
Just use the Pythagorean theorem, is that what I heard? Yeah, so we have negative 3 is our x, or negative root 3, squared,
Some people want to use a special right triangle.
or it's a special right triangle, yeah, you could use that too. Or you could use the Pythagorean theorem, whatever you want. Negative root 3 squared, 3 plus 1 is equal to r squared. What's your radius? 2. So the coordinates of our point would be 250 degrees. Okay, Silver, I want to get back to what you were saying. If we wanted to use negative 30 degrees, what would we want our radius to be? Not negative square 3. We just make our radius opposite, yeah. I think generally we're always going to be working with positive angles, but yeah, that would be how we do it.
So if I wrote that, I would get it wrong.
If the direction specified specifically that they want positive angle, yeah.
What's he? I'm sorry, I was correcting. What's he asking?
he said, I don't want to write radius of 2, 150 degrees. I want to write radius -2, -30 degrees, which is the same thing.
Exactly, but by definition of polar coordinates, it's always given as a positive. That's the definition of polar coordinates. So when you say r theta, theta is from the polar axis counterclockwise 150. I know what you're doing, you're going the other way, but by definition, give it to me positive.
Okay. We have one more. Here's your xy coordinate, 1.4 to -2. You have to solve that, and I'll check it off with you. I need to see everyone can do this before you go. 1.4 -2 is your xy coordinate. Find the polar coordinates. Agree with the radius. That theta is technically correct, but how can we make it positive?
Like going all the way around.
So what do we have?
360.
That 360 is -55.
Am I on the right path? Pretending
Yes, except for this. Your y is -2.
Does it matter?
Yes. It goes
Yeah.
y.
Why? That sounds so dumb.
Sorry, that's what I changed it sometimes. It will mess things up. Nice. Good job. So, I agree with the radius, I disagree with the angle. Sketch that point. Just right. Yep, that's great. Yeah, it's right in there somewhere. So it could be 124 degrees.
You should
Yes.
stop the recording.
Thank you.